In this video, I am going to talk about a root finding method known as method of false position. It is also known as regular falsy method, or it has another name, linear interpolation. In the previous video, we have seen a second method, and there is a drawback in the second method, that if the initial approximations on the curve is chosen like this, then the approximation will be far off from the root, and we shall never be able to find out root using this method. So in regular falsy method, there is modification to this, and here if we take a curve like this, then 2 points are chosen on this curve in such a way that they fall on the opposite sides of the curve. Now we draw a chord joining these 2 points, and wherever this chord cuts x-axis, that is the new approximation. Now from using this point, we draw another chord, and from that we get another approximation, and this way we obtain the root. Now the equation of chord is given by y minus f at x1 by x minus x1 equal to f at x0 minus f at x1 by x0 minus x1. If we assume that at x equal to x2 the chord cuts y-axis, it means y is equal to 0, then I can write down y minus f at x1 divided by x minus x1 is equal to f at x0 minus f at x1 divided by x0 minus x1. And from this, if we solve, then we get x2 is equal to x1 minus f at x1 into x1 minus x0 divided by f at x1 minus f at x0. The procedure is repeated till we find out the root. So the procedure is something like this, that first we find out a point where the root is, the function is negative, then another point where the function is positive. So the root lies in between these two. From this we find out another point, and then we evaluate function at that point, and if it is positive, then it falls between, the root falls between x0 and x2, and if it is negative, then root lies between x1 and x2. Now this I am going to show with an example. So the example is that we have to find out real root of the equation exponential x square minus 1 minus sin x minus 1 equal to 0. Let f is equal to exponential x square minus 1 minus sin x minus 1. Now we find out the function value at minus 0.7, and this comes out to be minus 0.7 square minus 1 minus sine minus 0.7 minus 1, that is 0.244713, that is it is positive. And at x1 the functional value is minus 0.632122121. This is negative, so it means root lies between minus 0.7 and 0. If we look at the plot, then the roots, there are two roots, and these roots lies over here. In order to calculate it, the next approximation can be given as x1 minus f at x1 minus x0 by f at x1 minus f at x0, and that is 0 minus 0.6322121, then x1 is 0 minus 0.7 divided by minus 0.6322121 minus 0.244713, and so from this we find out that the value is minus 0.50464. So the root lies between minus 0.50464 and minus 0.7, and this way we can find out x3 and so on. So this has been tabulated over here. This is our x0, this is x1. From this we find out the root, the approximation to the root. Then next value will be the root lies between x0 and this value. So next approximation will be this one, and this way we continue. We can see over here that one end in this method is always fixed. If we compare it with second method, then we see that if the proper choice of the initial values are taken, then the second method is faster than regular falsy method. The convergence in regular falsy method is linear. Now there are certain pitfalls of this method. Number one pitfall is that if the function is discontinuous, then the method may fail. Number 2, that if the initial approximation is taken far off from the root, then the convergence to the root may be very slow.